We will start. I'm Frédéric Dreyer. I will be there to moderate the roundtable, but just before to start, this is the first seminar series of the year organized by Mediacom, so I want to thank Joris and Nathalie for the organization tonight. So the event will be in two main phases. The first one will be a keynote from Corentin Fivet, and the second one will be a roundtable. In order to prepare the roundtable, we will ask you if you have some questions to scan the QR code and to put all the questions you have, and after, during the roundtable, we will open the floor to your questions. So feel free to scan the QR code and to rate also the questions, so we will choose the best rated questions, means meaningful for you. So before to start with Corentin, I will invite Katrin Beyer, our Dean of the ENAC School, Environment, Architecture and Civil Engineering, to make a short introduction and to introduce Corentin Fivet. Thank you.
Thank you, Frédéric, for these first words, and also a very warm welcome from my side to this first event of the Sustainability Series here at EPFL of this year. The series, of course, already started last year, and also from my side, many thanks to Mediacom for organizing it. The objective of the series, of course, to showcase research on sustainability that is done at EPFL. And of course, this is a very relevant topic for us at ENAC, who we are really sort of as the school that addresses sustainability in the natural and built environment. Tonight, it is really about the construction sector. And of course, this is a really important topic because the construction sector contributes to 40% of the CO2 emissions that we have. So there are huge challenges ahead of us in order to reduce these emissions that we, so that we can find in the end a sustainable way of living here on this planet. And it's really my great pleasure to introduce Professor Corentin Fivet. Professor Corentin Fivet is a professor at ENAC. And more specifically at the Institute of Architecture. He's the head of the Structural Exploration Lab, and he's now also, not yet, in a couple of days, he will be the head of the academic director of the campus in the EPFL campus in Fribourg. Professor Fivet is really an expert in the reuse of concrete in structural applications. He's really between architecture and structural design, bringing these two disciplines together in order to find real applications where we can use and reuse concrete elements in various ways in order to reduce CO2 emissions. Without further ado, it's really my great pleasure to welcome Corentin on stage. He's where? Okay, yes. Okay.
All right, thank you very much. Thank you, EPFL Mediacom, for the invitation. I think the sustainability series is very, very important event here at EPFL. Thank you, Katrin, for the kind words in the introduction. And indeed, today, I'd like to speak about waste, in particular waste from the construction sector. And for that, I will start with a map that you may not know. It's a map of Switzerland, but not the kind of map that you are used to see, because what you see here is that every point on the map is actually a demolition site. Okay, so it's a building being demolished in the past 20 years, roughly. In Switzerland, there are about 3,200 buildings demolished every year, okay, and that represents about 70 million tons of construction materials every year. All right, so that's a lot. It's not a number that we know because it doesn't happen in our everyday life. It's happening fast and so sometimes out of sight as well. Just to give you the full picture of where the waste come from in Switzerland, so we know where we are. So construction waste is the second most produced waste in Switzerland. The first one are soils, so excavated and drilling materials, excavated soils, 65%, about 20% for demolition materials. Urban waste, so your regular weekly trash, it's only 7% of that waste, and then bio waste, wood, food, 6%. Okay, so everyone in Switzerland is responsible for about 10 tons of waste per year. Whether you want it or not, whether you can control it or not. And the issue here is that we do very little with this waste. We are not valorizing the waste that we are producing. And the reason why we are demolishing buildings in particular is not because the material is of bad quality. It's not because building was about to be not safe the next day. Most of the time it's because we don't need the space created by that building at that location at that point in time. So we want to replace a building with a bigger one, and we need to demolish the building. But the material that is the output of this operation, the material is still of sound quality, and we should do something with it. We are mostly doing nothing with it today, but it wasn't the case in the past. There are numerous examples before the Industrial Revolution in particular, where it was just common sense to reuse pieces from one building to a new building. Here is one that I love to present. So it's a bridge built in 1810 over the Rhine River at the border between Switzerland and Germany. 1 century later, so in 1919, the local communities decided to replace the bridge for a bigger one, for a taller one, of course. And monks from the village nearby managed to reclaim some of the timber pieces from this bridge in order to build the barn that we see below, a barn that is still standing today. We can actually see the cuts in the columns of this barn, and those cuts correspond to the location where we had connections in the former bridge. So what we have here is a building that is 100-year-old, but it's made of 200-year-old materials. So we have materials that have a longer lifespan than the building they are part of. Today, if we follow the same principle and upscale it to its maximum extent, we could reduce greenhouse gas emissions up to 90% per reused product. It's not true for every type of reuse, but it's true in particular for the type of reuse that I will show in the next slides. We could reduce up to 40% of waste in the country. We could avoid extracting raw materials 10 to 25%. It's a new way of reacting or living with heritage, so where the materials have a story to tell that is different or longer than the building can tell. And also the reason why a lot of cities in Europe, but also Europe in general, are pushing forward this paradigm of circular economy. It's because it's also a generator of local, non-externalizable, renewable jobs. Because we need people to work locally to extract those products carefully, to repair them, and then to place them in new buildings. So it was common sense today, and the question we should ask ourselves is whether we can, whether it can become common sense again today or not. And what we see is that currently there are barriers, but there are not really technical barriers. I will show that. There are not really logistical barriers, and probably that also most of the times not economical barrier either. But what we believe is that the main barrier is a barrier of perception. So we are afraid of engaging into this new activity just because we are not used to it. So it's the fear of the unknown. It's not that it's a bigger risk, it's just that it's a different type of risk that we are not used to. And it's very hard for the industry, for everyone to actually go out of our comfort zone and take new risks. And so that's why what we at the Structural Exploration Lab with teams of researchers in architecture and structural engineering, what we are trying to tackle, to work against this fear of the unknown. And there are two things that we are recognizing, and that I will show in the next slides. The first one is that mainly it's a matter of design. So I will speak about designing with waste today. And it's also a matter of trusting the capabilities of waste. And for that, to explain what I mean by that, I will start with a type of waste that we are not using in the construction industry, but it's very symptomatic of the issues that we have to tackle as designers when designing with waste. So in Switzerland, France, Austria, there are tens of thousands of skis put into the trash bin every year. And ski is not a very nice waste because it's a composite material. It's very hard to recycle. You cannot decompose the materials into subparts. It costs too much, so it's just burnt in the best case scenario. But at the same time, what was the waste for the skiers may not be waste for other people. And waste has a quality that we can try to recover. Skis and wasted skis have a quality that we can try to recover. If you think about it from a mechanical point of view, the skis, they bend very well in one direction. They are very stiff in the other direction. And that's something that we could use to build structures, for instance. Even though we don't know what these skis are made of. Every pair of ski is a different pair, a different composition of material in the ski, and we cannot spend time to actually have the full data, the full information of all mechanical properties of these skis. And to show that as designers we're able to design safe structures even though we don't know everything about the material, we built this freeform shell made of skis, and there are a number of challenges related to that. We don't want torsion in the skis, so it means that the ski should follow very specific lines. We want to have flat panels. If we have 4 points in space, it's not always that, those 4 points will be on the same plane. We want also to have a construction process that is fast and efficient, and eventually we also want to have a stable structure. And this approach, so the idea that in every way there is a technology that is worth recovering. We actually applying it with bachelor students in architecture, civil engineering, and environmental engineering. So for 1 week, we asked them to design a new product. That year it was a table. And they have 1 week to first identify the sourcing, so where could the material come from, here left over from local production sites, how to transform this material and how to combine these materials in order to build a table that is usable, that has all the qualities of regular tables. From a structural design point of view, we have the exact same question at a different scale. So in conventional design, probably we would start with the sketch of the overall structure. This is on the left-hand side on the top. And then after structural analysis, we will have a good understanding of what should be manufactured, and we'll eventually manufacture all the pieces of the structure. If we start from a stock of materials that we recover from, or that we mine from the existing structures, the problem is different because the quantity of elements is given, the materials of these elements are given, the dimensions of these materials are given, and now the new problem is to find what is the best assembly for the structure in order to use this reclaimed material in the best way possible. Again, another case study to illustrate this. So it was a work done by a master student where the idea was to see how we could recover steel elements from these pylons from an electric line in Vallis in order to build an extension for the Lausanne train station. And if we think about the problem at hand here, there are 3 questions that we have to solve simultaneously. First is this one, so where to get the material, so what elements are worth being recovered and being used in the structure. Not element is reusable. Some elements are more interesting than others. The second question is where to put these elements in the new structure. So in order to avoid oversizing, we cannot control and manufacture the section of these elements in an optimum way, but we can try to minimize the oversizing of each section. And then eventually the third question is, what shape should we give to the structure? And these are three questions that can be optimized with algorithms, and that's even more interesting to automate the process, because most of the time, I mean here for the pylons, but every time you want to reuse, you have to deal with a stock of material that is highly heterogeneous. Most of the time you don't have two of the same elements. Every element is different. It's not something that you can do by hand. It's easier to handle this diversity with algorithms. And so we've developed algorithms actually to help this automation and optimizations. So how to select reuse components, newly produced components, and how to make a good structural shape with those elements. If we apply life cycle assessment, this is where it becomes interesting. We see in the case of steel structures that reusing components can divide CO2 emissions by two, so all emissions related to the production of the truss here in particular. And something that is also interesting and that could be extrapolated to other types of reuse activities. If we really want to be clever and reduce to a maximum the greenhouse gas emissions, then it's also good not to be dogmatic and to allow newly produced components in the system. So here in particular to replace the oversized members with newly manufactured one. And that's something probably that could be extended to other type of reuse activities. So I spoke about timber, steel, and now I would like to speak about concrete. Why? Because concrete is a material that we use the most currently in the industry. It's a wonderful material. We can build almost whatever we want with concrete. But at the same time, and because of that, or thanks to that, concrete, the production of cement in particular is responsible for about 8% of global CO2 emissions. And waste also represents about a third of all the waste of the construction industry. And that's because we are using it everywhere. If we look at a typical building in Switzerland, also again to give the full picture, in a regular building, a third of the greenhouse gas emissions will be related to the production of concrete, 23% will be related to the production of insulation, 18% for minerals, and then bricks, wood, metal, glass, and waste. And most of the greenhouse gas emissions related to the production of concrete actually come from the production of the slab in buildings. This is where we have most of the technology in building. Currently, the best end of life for concrete currently on the market is to produce recycled concrete. So what it means that we get the old concrete, we crush it into small parts, and we use it as aggregates into a new concrete. But for that, we have to add also natural aggregates. We can only replace a portion of all aggregates. We have to add water, sand, and cement, and we have the recycled concrete. And because we have to add this cement and sand, but mostly cement, the greenhouse gas emissions related to the production of recycled concrete are not really better than the greenhouse gas emissions related to the production of a regular concrete. So while it's important to recycle aggregates to avoid the extraction of natural aggregates, we should also try to delay the production of recycled concrete. And how to delay it? By cutting the concrete properly and reuse all the technology that is already there in the concrete that is about to be demolished. This is not a new idea. There are examples in Europe of entire buildings being dismantled. So here is an example from the Netherlands, where the building on the left-hand side has been dismantled. So it's a building made of prefabricated concrete panels. And the slab panels, the wall panels have been disassembled and reassembled to build the new building that you see on the right-hand side. From the outside, you don't see a difference. It's just a regular building. No one know that it's actually reused concrete. But from a life cycle assessment, there is a huge difference from regular construction. A PhD student, Celia Kupfer from the lab, actually did some research to collect all these past examples, and whenever there was a life cycle assessment provided or an economic assessment provided, she collected it here on this graph. We see that in all cases there are savings, and savings in terms of waste, savings in terms of CO2 emissions, if we compare with the regular alternative. And from an economical point of view, sometimes we lose money, sometimes we gain money. Sometimes the financial balance is positive, and it's actually the case when the owner of the building to demolish is also the owner of the new building to build. And we could explain that by the fact that the logistics between the demolition site, the new construction site could be optimized. We can avoid the need for storage. We can also anticipate the deconstruction and also have an economical balance, because we save money by not demolishing, by not crushing the concrete and send it into landfills. Most of these examples actually are made of prefabricated concrete, so precast panels. In Switzerland, it's not a common construction type. Most of the concrete that we are demolishing is actually cast-in-place concrete. And so to demolish it, we need special tools, in particular diamond saws, like we see here. And this is a common technique that is used every day in the industry, mainly whenever there is a building to transform. Here is a prototype that we built 4 years ago already. A cutting company had to remove walls from an hotel that was only 10 years old and already being transformed. It made sense for them to cut small pieces because they have to move them from the underground to the ground level. And we collected those pieces, assembled them together to create this fruit bridge arch. And if we do, again, a life cycle assessment, we compare this bridge made of reused blocks with another bridge that would be cast as in one go with recycled concrete. We compare it with another bridge that would be made of a steel arch beam, and the fourth one is an arch made of timber. Then we see again savings in terms of greenhouse gas emissions. We also see that the greenhouse gas emissions are almost similar to the one of the timber arch. Timber, as a construction structural material, is seen, understood as one of the most sustainable material today. And here there is a new competitor for the most sustainable material, which is reused concrete. We should build more with timber, of course, but whenever we need the qualities of concrete, of regular concrete, then reusing concrete makes absolute sense. Since then, there have been a few applications in the industry, especially here locally in Switzerland. For instance, here, concrete that was cast and used as road pavement in Meyrin. Again, if we do a life cycle assessment, we see very interesting savings in terms of CO2 emissions, comparing it with pouring new concrete or even regular bituminous overlay. This is very interesting, but concrete is more than just a material that resists well in compression. There are still reinforcement bars in concrete, and this is the actual technology that we want to reclaim. And so if we want to reclaim the steel, we want to use the reused concrete as a bending resistant material. And one application showcasing that is this ongoing project that is led by students here at EPFL. It's an EPFL make project. It's called Rebuild. If you don't know about it, I invite you to check the website. There is a nice video explaining the latest development of the project. Basically, we help them to cut not just blocks and not just slabs, but modules of 2 slabs and 1 column in between, in order to actually reuse the steel rebars that are there at the connections. In concrete, we put the steel rebars at the connection, so it makes sense to reclaim the connection and reuse it in the new structure. It's a very interesting project. There are 2 students from the project who will be participating in the roundtable afterwards. This spring, late this spring, straw bale walls will be assembled. There is also a roof now on top with reclaimed tiles, and it's a project made in coordination with the local kids from the school nearby. Here is the sourcing of those modules, so slabs and columns. Actually, other research projects managed to reclaim other pieces, other concrete pieces from the same building. So the entire slab and the entire floor was actually cut and reused in different projects. And we could consider it as the new production factory. So this is the new mine. This is where the new construction material should come from. And as I said, most of the CO2 emissions related to the production of a building come from the production of the slab themselves. And so it makes sense even more to actually cut properly the slab and reuse them as new slab. And this is the result of a recent research where by combining cut slab with reclaimed steel beams, we can build new floor slabs with the span that we want. And if the building, the reinforced, the concrete building that is about to be demolished was actually built after 1956, then we can show that we can, and if the span of the slab is no more than 3.5 meters, then we can show that it can be reused today with the current norms, with the current standards of construction as a new building slab. So it has the same quality as a new slab, but it cuts the greenhouse gas emissions by a factor of 10. And currently, you can build a floor in timber, in other materials. You will achieve savings, but you won't be able to have a global warming potential that is as low. Of course, those pieces are heavy, you need to transport them, but the reduction, the greenhouse gas emissions, the reduction that you can have are so big that it's okay even to transport the pieces for 500 kilometers. You would still have a savings of up to 75%. And those slabs, we are demolishing them on a daily basis, so maybe we could consider the batch reuse of these concrete slabs. We know that there is a need for new slabs, so let's reuse them. And probably that from an economical point of view, it doesn't make sense to precisely cut every piece of the building to demolish. Probably that what makes sense to reuse properly are the slabs and sometimes the wall, and all the rests would be crushed with regular tools. And so we are also exploring what to do with this regular rubble. We are not the only one. The EESD lab here at EPFL is also researching on that with small pieces. We are considering here big pieces and looking at how current traditional equipment that we have on construction sites could be hacked or enhanced digitally to fasten the process. And the question is how to replace a robot with regular machine that would be enhanced with new sensors, for instance. So everything, the concrete is good. From the rubble to the blocks, to the slabs, walls, beams, and assemblies, there is a different application for reusing this concrete. And this is probably something to develop. But even if we develop it, we won't solve the entire question, because currently in Switzerland we are demolishing only one, I mean, the volume of material that you are demolishing is only 1/6 of all the volume of material that we need for new construction. So we are constructing about six times more than what we are demolishing. And so if we want to have a real impact on this, on reducing greenhouse gas emissions and at the national level, probably we should do more than just reusing the concrete, and we should also avoid constructing unnecessary buildings, and also avoid demolishing and avoid operating unnecessary demolitions. So this is the end of the talk, but before concluding, I wanted to use this slide as probably as an introduction for the debate, the roundtable that will follow, to give a reminder of the current context. So the big dark line is the historical evolution of CO2 emissions in the atmosphere since 1970. Then at some point, scientists started to measure other greenhouse gases than CO2, because it's not only about CO2. And this is the other dark line that we see on top. And then on the right-hand side of this graph, usually we have these as two separate figures. We have the figure for the left-hand side, we have the figure for the right-hand side, but it's not common to have the same figure, the two curves as one figure. So what do we have on the right-hand side? We have an estimation of what is needed as greenhouse gas emission reduction to avoid global warming. So if we want to maintain warming under 1.5 degrees Celsius, then this is the first curved, the first reduction that we should achieve. The IPCC authors understood well before everyone that it's probably a target that we as a society on Earth won't be able to reach. So they also give us some target for the 2 degrees warming. And to express how difficult this will be, how difficult this will be. They also show the upper curves, which is the estimation of greenhouse gas emissions if we maintain the current policies, if we maintain also probably the current way we do research for our scale. And the construction industry is responsible for 15% of all these CO2 emissions. So I light it as an open. There is no question. I don't even know what question to ask here. I mean, we will be able to achieve those targets. Probably no. So how shall we react to that? There are many different ways of reacting to this. And I let it as a starting point for the discussion. With that, thank you very much. Thank you.
Thank you very much, Corentin, for giving us that first historical overview on how reuse sort of is embedded actually in the DNA of the construction industry, or was embedded in the DNA of the construction industry, and we really have to now bring it back to our practices. And then also outlining how that can be done, including showcasing really these examples that you have really developed with your lab. It's really, I think, very promising avenues and very needed avenues. And with that, I give the floor to Frédéric, who will introduce the speakers of the roundtable and moderate the roundtable.
So, perfect. It's time for the roundtable, so to exchange. So I invite you again to scan the QR code if you have some questions. Don't hesitate, you are there also to share your fears, your questions, and so on. So I will invite Katrin to join us, also Luana, Sarah, Renaud, and Corentin, you are already there. I will try to put some incentive also, but you know, yesterday and today are special days. There is some information coming out from EPFL or other stakeholders on today, far away from the topic of the real estate or the construction, but Enterprise for Society, a joint venture of center between UNIL, EPFL, and IMD, launched a report with Richemont Group about zero waste emission and circular economy in the field of watchmaking. So it's a huge trend also in watchmaking, how to be better in a suitable way and to reuse the waste for watchmaking. Why not? So the idea of the exchange today is really to share different vision, something quite important for us at the EPFL. We are part of an ecosystem. An ecosystem is a value chain with different stakeholders from the public, private sectors, regulation for sure, the public policies, as we said, and you already finalized with the conclusion. And the idea of today is really to have different representatives from these different fields and, I will say, horizon. So we will start first with a short introduction, with a short question. So the first one will be for Karen. Yes. So Karen, first of all, yes, you are super well known in the concrete and cement world and so on, but my first question, can you, because we are looking for how to have an impact for the society and the economy and for the citizen, for the world. There is no planet B, seems to be. So you are at the roots of the LC3 and the new worldwide sustainable centers. The idea is to be part of the value chain to have a global impact. One of the key options can be also the open source, to open the solutions to the main and the wide horizon of different actors. Can you share a bit more about the vision about this local to global and how to have an impact from EPFL and outside? And where are the challenges, I will say, at the end?
Oh gosh, that's a very complicated question.
Yeah.
I think, first of all, we have to follow all possibilities to tackle this problem. There's no one single solution. When it comes to cement industry, what we really have to be aware of is that we're seeing tremendous shifts in the pattern of use. So the last 30 years has been dominated by what's happened in China, but now consumption of cement in China is going to really nosedive, and we're going to see other developing regions taking over, like India and particularly Africa. When we're looking at new construction, we have to look where it's happening. We developed this alternative cement. I mean, it's based on existing ideas, but it was just a remanipulation of existing ideas called LC3, which can save these. We estimate the potential per year is up to like 800 million tons a year. So far, we've maybe saved 2 million, so we're only a small part of the way here. But it was very important that we did this in an open way. We didn't try to patent this technology or set up our own startup. It would have been meaningless trying to erect our own cement plant when you have 3,000 around the world. And, it's not just producing, you have to think of all the supply chain afterwards. So really we concentrated on getting the message out to people. Everybody always says to me, well, why isn't it going faster? Well, I wish I knew, because it's, I presented and everybody said, well, why aren't we doing this? There's so much inertia in the system. I think this is what we see on Corentin's last graph. There's so much inertia. People just keep doing the way they've been doing things the whole time. And you really have to put in this huge effort to start to change anything around. But, people say to me, well, it's too late. No, it's never too late. You can always make things less worse. And I think that's how we have to think. We still have to put all our efforts to do what we can, Otherwise, personally, I have 2 grandchildren now. They're going to be only 70 or 80 in the year 2100. It's amazing. Sorry, that was rambling on, but you asked me a rather complex question. I hope I kind of partially answered it.
You give key message, it's not too late, and everything is open way. And I will say also it's to break the silos.
Yeah.
Because if we are looking on the real estate value chain, is a super complex and decentralized. So we need to have also a commitment of the value chain on that and to break the silos. So if we are talking about the break the silo, it's also coming from the research, the academy, and to be students, but to discover what is really the real life. When I finished my studies and I entered in the industry, I was, EPFL is super cool, but at the end, the reality is more in the industry or the society, to be honest. So we have the chance today to have 2 participant, or I will say activist in the project of Make Rebuilt. So perhaps you know or not, but at EPFL we have a program called Make. The idea is the cross-fertilization, means to have transversality and to have different, I will say, expertise, students working together and to have an impact. And today we have the opportunity to have you on board, so please can you share first what is the goal of Rebuild project and mainly what are the main challenges? To be super honest, what are the main challenges? Is really from the industry, from the academic, from where is the bottleneck or bottlenecks at the end? Please.
I'll first start with
Yes.
what is Rebuild.
Yes.
So it's a student-led initiative where we experiment with alternative construction methods. So we're currently 10 to 15 core students, core members. And then we're accompanied by currently 30 other students which are credited for the projects they make and supervised by students from our association as well as academic members. So in total, over the last 2.5 years, it's 200 people involved in the Rebuild project. So it first started with exploring low-tech principles in an urban context, which then evolved into the communitarian pavilion situated in the Écublon, next to the school of Écublon. So aside from the low-tech and reuse principles, where we saw the structure, where we reused structural elements in concrete that we extracted from a building close by, we also are driven by a participatory approach where we involved the future users in the design phases as well as in the construction, which actually led also to the choice of bio-based materials, which are straw and earth for the construction and the envelope. And I would say our motto is learning by doing, which is a great opportunity for our students, but also we actually realize what it is a bit in the real life. So regarding the challenges of legal and normative aspects of what it is to build a public building, because it is open to, well, all the community, and Sarah will talk about it.
Yeah, about the challenges.
Yes.
There are so many. I will start with the first one. I think is the most important. There are still a lot of people that just don't understand what's going on. And this is extremely difficult to put forward a project like this when the people that are in front of you, who you're interacting with, don't understand that our world is changing. It's changing fast, and it's gonna be a dramatic thing that's happening. This is probably the main problem. But then otherwise there are a lot of other things. I will say just a few, but we're in a big structure. EPFL is like a giant corporate. You're trying to put such a project forward in such a context is difficult. There are long and inflexible processes, but I think it's in every industry like this. It's just a nice experiment for us, but not very easy. And then everything needs to fit in a box, especially it needs to fit in a single box. And with a project like this, you just can't tick a single box. We are doing so many different things. It's normal that it is more than just a box, and it doesn't fit something that is existing. So that's always difficult to explain as well. Then in a context where you need to do something, it's super difficult in big structures to understand who has the capacity to do a change, to make a decision that can help you out. It's most of the time not the person who has the title to do it that can actually help you out. Big learning for us. And then there are norms, there are laws that generate inertias, but that also require from us to enhance the trust that people have in us, which is not always easy, especially if you're students. I think there EPFL is helping a little bit, because when you come to someone and you say, yeah, we're from EPFL, then maybe they recognize you a little bit more. But even within the school, it's always difficult to be heard. Then insurances, which I think is a very interesting topic. It's very hard to insure a project like that. And it's funny because in a way, who is going to pay for the damage that we are doing right now? Of course, the people who are going to experience it. But then in the end, it's also the insurance for the building that are actually insured, or the things that are actually insured. But at some point, it's highly probable that insurances won't be okay with just paying for the damages that an enterprise has done. And so they can really easily say, yeah, we just don't pay for your damages, and because you acted irresponsibly regarding the environment. But now they're still blocking innovation. So it's an interesting position in which they are in, and it's not always very easy to navigate if you have to insure a project like this. And very stupidly, we really wanted to have children involved in the project. But if you want to have children involved in a project like this, you need to have security shoes in size lower than 34, which doesn't exist. And so you cannot have children in a project like this just because the security shoes doesn't exist in that size. So it's always problems that happen in the very weirdest places, but you just always have one. I think that's going to be it for now.
Thank you, Sarah. So we have a concrete example in the concrete case of the reuse. Sorry. I'm tired, you know, it's the end of the day. But now the question also today, perhaps you saw, but you know the Tour des Cèdres? And there's a post from Woodby this morning. The Tour des Cèdres just across there now is from Orlati. So perhaps you know, but it's 100 meters. And there is greener facade with the trees and so on. But at the end, many using what? Concrete. And perhaps the wood can be also an option. So when you are in the real estate, you are an asset manager, asset owner. I'm just talking about you, Renaud, as the operational director of the group M3 in the real estate. Can you just present a little bit also the challenges as asset owner, asset managers on this promoter, immobilier and so on? And a part of the challenges, what is the importance for you to be greener? Means you have a portfolio of assets. You are in the private sectors. We are talking about sustainability, but sustainability is also perhaps linked to the business and the cash flow. So how you balance as a private company?
Yeah, well, first of all, thank you for the introduction, because the problem you face at your own scale is the same that we face at our scale, and our scale is way much bigger than yours. The reality, and that's maybe the good news of the day, real estate have been facing a revolution for the last 10 to 15 years. As you've said before, in the early 70s, 80s, even 90s, we were just like demolishing, building. We didn't care about what it should become after. It was for 10 years or something like that. If you see what is happening still in North America, when you build a house in North America, that's for 10 years, not just even a family, just for one person. So today the revolution is due to the fact that we are facing the limit of our industry. The limit of our industry is that the first one is the land consumption. And land shouldn't be a waste at any time. So it's a precious element. And today the good news is that on our side as private investors and developers, but also on the side of the end users and on the side of the state and the cities, there has been a lot of incoming regulations, but I would say positive regulations. Now we take the time to understand what are the real needs. We take the time to understand where we should densify and not densify due to the infrastructure, due to, I would say, where we work, where we live, where we play. You heard about the 15-minute city. That is something that we always have in mind, whatever we try to, I would say, design and build somehow. The other good news is the fact that I would say designing, creating new buildings today, I would say, is not a real focus point in my mind, except if we don't take into consideration reuse of existing building, not as demolishing and rebuilding with it, just reusing it. But we are facing a huge problem today. That's we should still do more. There is more population. People want more comforts with less. And this is where real estate industry is not alone and shouldn't be alone. We need to be accompanied by politics, by sociologists, at any time in any project, to better understand how we could just change the way we design and create living spaces. Just an example. Today in Switzerland, when you want to have a family flat, I would say if we propose to you a family flat less than 110 square meter, you will never take it. You will never understand why it's going to be so tiny. But go in France, go in Belgium, go in just next to us. In France, a family flat is 65 to 70 square meter. I think that's 50% less than what we built here. So what is very important is to move the needles of the society, move the needles of the need, and move the needles of how we integrate the fact that the new way of living should encourage us to do it better with less.
Thank you, Renaud. So one of the key messages is that we need to act a change for sure, but all the value chain. So it's also the citizens, so the end users perhaps. But now I would try to focus on the question you sent. So I would try just to regroup some of them. There is the question about architects, students are the best target to make this awareness about the challenge linked to the sustainability. Engineers also, they want to be more sustainable way. There is some also perhaps challenges linked to the insurance company and regulation. So the first question for all of you, we have solutions, they are there, but why we are not able to deploy and to accelerate the change? Is it linked to the regulation? Is it linked just to the behavior? Is it linked to the business side? The frustration is there, for sure, everything is in front of us. Is what you want to do also with the worldwide center, things that we are there, we have the solutions, how we can act the change. So how we can move the line as an engineer, as a student, as a citizens to deploy and to foster the impact in the real estate and constructions. Do you have a secret recipe to bring the people together, to create living labs, to showcase that it's feasible?
I can start with the easy answers. First, there is a lack of awareness. I mean, many people in the industry or clients are not aware of the scale of the climate issue first. And so, I mean, if you don't know, why change? And then regulation may help regarding that. But then and for me, it's a matter of those who understand that there is a need to change should try, and little by little, experiments after experiments, little developments after little developments, things will change, and we need to build precedents and show that it's okay. I mean, it makes sense to change the way we do usually. Yeah, that's the easy answer.
Maybe building up on that, I think there is a massive need for new skills, both in how do we learn those new things, how do we do them, I mean, it's normal that someone doesn't just start to do a reuse if they have never been explained how it goes. But then also, how do you work in a team when you're doing a project like that meets so many different topics? Like we have learned, it's not always easy, but it's super interesting, and it really needed us to learn a new way of working with each other when we were working across fields like that, but also in communication skill. Like, how do you raise awareness? You also have to learn how you can communicate with someone without scaring them away, which is sometimes what happens, but truly being honest as well. And that, I think, is something we really still lack a lot of capacity in.
Yeah, I think there's no simple answer to this question, but I would like to sort of make a word of caution about, I think sometimes we are a little bit in our Swiss European bubble, and we have a very nice level of life here. Renaud was talking about the large size of the houses, and at the end of the day, we could maybe reduce all Swiss emissions to zero, this still wouldn't solve the problem. But our glaciers would still be melting. So, you know, I'm also, I mean, I encounter this a lot. You know, when I make my presentation to architecture students, they say to me, oh, it's simple, we just stop building. You know, and I say to them, you go to India, you see the people sleeping in the streets. Mm-hmm. You're going to say to them, we just stop building? You know, it's not realistic to apply these blanket solutions. We need lots of different solutions. Education, of course, and making people aware is one thing. But I think we also have to use the opportunity of the good fortune we have in Switzerland. You know, in my own lab, we've had over 50 different nationalities coming through the lab in the last 20-odd years. You know, we try and host, we're very lucky in Switzerland to have this Swiss government excellence scheme. It's a great scheme. We can have people working with us for a year, then they go back, and often we continue to collaborate with them. So, you know, it's no simple answer. We need everything, but we also need to think, you know, worldwide. This is why when we created the Center for Sustainable Construction, I really insisted it's called Center for Worldwide Sustainable Construction. And we need to work not just on what we can do in Switzerland, but what we can do in the whole of the world.
The key message that, Renaud, I will let you after, but the key message is that the challenges are not really in Europe, but they are in this Indian sound on awareness, education, and to make from centralization, decentralization, and to bring also this education, best practices worldwide to have a global impact for a global planet.
Yeah, I would jump on that. I think it's, if we just think about what we could do as a local perspective, we could do whatever we want. I mean, we have the money, we have the intelligence, we can buy the materials, so we can do whatever we want here, and it's going to be qualitative. Everybody will just say, that's perfect. But the real question is, if we consume what we need here, what will be our impact on it? When we see, we know with Corentin, if we renovate the 1.8 million building in Switzerland, we will gain, I would say, almost 2.5 times what we use as energy today. If we will use the same amount of material, human resources, energy to do that in another country, what will be the multiple? Maybe 7, maybe 10, maybe 20 in some circumstance. So I think the arbitration is: should we do something? Should we do all? Should we do just part of it? Should we subsidize what could be done elsewhere as a global perspective? And I remember a funny conversation I had when in Switzerland, if we want to, at an average of 2050, if we want to renovate and to be, I would say, more efficient, we need an additional 250,000 people that are not already on the market. That's new brought people to the market. And we are starting thinking of subsidizing university in some emerging country for them to be educated to renovate our own building. So they are going to be educated in their country and they're going to work for us here. I mean, sometimes we should think in a different way. And that's where I jump on that. That's more global.
If I may, I will just repeat what you started with. Indeed, we are able, and we have the economical stability as well to make a change already here in Switzerland, but we are not doing it. And so it's even, I mean, indeed we should tackle the worldwide issue, but it's even more annoying that we are not even capable of tackling the local issue. And just to give an example, I mean, it's we should do more than what we can, and if so, I mean, those are both issues that should be tackled. Yeah.
Luana or Katrin?
Yeah, I think we did very well in Switzerland. We built a lot of dams in the 50s, 60s and 70s. And this is really, means we have a very low CO2 footprint for the electricity. It also means it's challenging to make further changes. As you said, the amount of money we would have to invest to fully renovate the buildings. In fact, somebody told me yesterday that the highest cause of CO2 emissions not CO2, greenhouse gas emissions in Switzerland is actually the cows. What are we going to do there? Are we going to get rid of all the cows in Switzerland? No, I don't think we are. But, this is the kind of issue we're facing. So, of course, we need to do these things, but we also need to think, where we can have most impact worldwide.
I think there's also a consideration of beyond the construction phase, that also the operative phase to take into account. And, well, you talked about comfort in terms of spaces, but if we think also about thermal comfort, how we think of it, what we learn also in the academic sphere, for example, just 1 degree less would be 30% reduction in the economy reduction, so both economical as well as energetical. And I think there's also a challenge in the way, the courses we have on comfort and how we think buildings, and also we think about comfort individually, but if we need to reduce also our way of living, we should also rethink, we live as individuals, but also as a collectivity. So is it only renovating building the envelope, making them hermetical, or is there also an organization that needs to be think differently?
Interesting. One point also to open after to another question and try to reshape also what I can read, but I'm also a founder of an association at EPFL called Fustic, and there are more or less 200 members, 60% coming from the private sectors and 40% coming from the real estate. So it means there is a commitment to come, and mainly coming from SMEs. And this afternoon with Sarah and other persons, we have a discussion to create, I will say, a proof of concept or a demonstrator of reused building. And the two things coming out is first, impact measurement. Today, we need to have standardization about impact measurement. And the second remark from Sarah was, as an SME, and we have the expertise in Switzerland for the reuse. It's not new. It's not something coming out from the last 2 years. We make reuse since dozens of years. We have the expertise, but we need also to have practical tools and standardization of tools, and all together we can use it to have an impact. Something like that, if I'm right, Sarah. The question now, how we can foster also all this point of standardization and so on, coming back that we have the solution, but to make standardization, to have impact measurement, what we can do to commit. Because the other point is that today, impact measurement is super important linked to the regulation. Perhaps, but the regulation changed from the 1st January of this year for the companies in the listing, so means in the côté en bourse, and also the private banks. And they don't have to produce only CSR reports, so the corporate social responsibility, but to have a climate change action plan with impact measurement. If not, they are not reaching, they will pay. So you are a polluter, you will pay. But we need to have impact measurement. So all this ecosystem of the econometry and measurement, so how we can together put all this point of standardization and tools and to we already discussed about open and to open as much as possible, but what you can put on the table linked to that? Because one of the remarks was, I try to use, but not really civil engineering and helping, or the insurance, or blah, blah, so it's not easy. So what is the way? So we are turning around the same question. I'm sorry, but I'm not satisfied with the answer. I know it's complex, but...
Okay, je me lance. No, I saw people in the room that are moving the needles as well, and the consciousness of that has begun, I would say, 7 to 6 years ago, where in the portfolio from the pension funds and private equity investors, before that they would just have a few measurements trying to be green, so it was more a greenwashing system that anything that went into actions, I would say. But now for the last 6 to 7 years, and it was even before regulations, it's the fact that the good news is the value of an asset today, so a value of the building on the market to be sold, is going down on a daily basis if you don't do something that commit to something that is better in the future. And today every single building is assessed on this side. Now we are starting to see, and we are starting to produce on ourselves, but you produce as well, and the pension funds and the owners of building, they're starting to plan on a 50-year basis what they should do in their own portfolio to move the needles. And they do that in a way to invest as soon as possible where they have the bigger impact and later on the smaller impact. And I think that made the change. This morning there were a conference in Geneva from the CIFI, and they are talking about valuation of buildings. And ESG now is a standard where people need to commit. And also, as I said, if you don't commit to, if your building is not meeting expectations, the value is going down. So any single owner of a building today needs to do something. I mean, it's finished. You're not gonna see the market going like in the sky with buildings that don't meet the expectations that we should have, I would say, here in Switzerland.
I've got a geeky question, so I will take the, not geeky, but just for, I think it's for you, Corentin. It's the top-rated one. So how to estimate the lifespan of a structure made of reused concrete elements? We are coming back to the impact measurement, but it's the top-rated question. So we have some engineers there, I think.
So I mean, there are two things, maybe. I mean, there are two types of questions there. So I'm not sure it's the right, because there is the lifespan of the mechanical quality or the physical quality of the concrete. So what is the lifespan of that concrete? And then maybe the other question could have been, what is the typical lifespan of a building to consider whenever doing this life cycle assessment with concrete? And in both cases, I don't think we should have an answer. I mean, it's okay not to care, because so that's the answer. Because we are the lifespan of concrete structure. I mean, so the concrete that we are considering in particular is the concrete inside the building. So it's protected by the envelope. I mean, it's gonna be there for decades and decades and decades, way before there is a need to transform the building or to demolish the building. So we are demolishing buildings too early with regard to this quality. We don't even have a sufficient feedback to actually assess the lifespan of the quality of this concrete once it's well protected inside this envelope of the buildings. So that's one answer. And then for the life cycle assessment, because we only look at the upfront carbon emissions, we don't need to consider. We can consider an infinite lifespan for the building. It's not part of the equation. It should be an infinite lifespan. So that would be the answer. Yeah, feel free to.
I think the timing, we are more or less at the end, right? So more or less. So I don't know, on your side, you want to give a key message also to the audience, but really to help to commit them to join the force, because it's also the message you are challenging. It's not only the question of expertise, but we need to have a really transversality. But what is the key message to commit and say, okay, you know, perhaps you are a citizen. There was a question that, are you trusting a building where we've reused element? Is it something trustable and so on? So there is also all the question of the trust and so how to bring the people to commit and to say, perhaps we are at EPFL, so perhaps you are coming from the EPFL world, but what will be the key message to deliver? Say, join the force, and we are able to do that, and we can act the change. I know, again, it's perhaps a difficult question, but how we can commit? You are change makers, huh? For me.
Yeah, maybe I would jump on what you've said. We need to break the silos. We are one and the others a little bit too far away to really understand what could be the impact that we could have if we join our efforts. I see some students that are trying to experiment things. I see studies and first next to what could be achieved, I would say on a local level. I see what we talked about a global level. We could also invest time and energy and money into, I would say, taking that and assemble that. So, but we are too far away. We don't talk too much. But what we could do, as we know that that real estate is an old bear that is like very, very not that much efficient and mobile. We should use this time, the time that we have, not taking decisions too fast to demolish. Rethink about what we can do of the existing assets that we have, and make sure that we offer the possibility to be to waste less and to reuse more.
Renaud, before to let the floor, there is a picky question for you. I'm sorry, but someone went on the website of the M3 Immobilier, and the sustainability is not really appearing as one of the key message on the key priority. But we need to
That's right.
awareness on some. So could you tell us what is the company doing to encourage green investment in the real estate, as it's not really promoting on the?
No, there is mainly three things. The first, our activities mainly. The first one is real estate development. So we are investing into future projects. Often we are very inserted into the existing assets. We do have a lot of projects in PAV in Genève. We are mainly located in Genève, and there. What we are trying to do is to replace, not reuse, but replace. And the interesting things there is, if you know Le Pave in Geneva, that's I would say that's an industrial site that is one of the biggest in Europe, 200 hectares, where you do have industries starting in the early 60s. So that's quite a recent area that needs to be densified due to the fact that there's additional elements. And there, what we are trying to do is to replace. I mean, from one industrial building, we try to elevate a building on top of that, or to and create residentials. There's 3 areas in Mérin and Plan-les-Ouates where there's available spaces. So we try to replace those elements, those industries there. Not rebuilding for them, but just freeing the space to densify. That's on the development side, and in this process, I would say, as I said, there is not much to be done than following the, I would say, the existing regulation, because the existing regulation is quite advanced there. The other thing is, the second one is on our asset management side. We do have something, the portfolio that we manage is worth 5 billion. Market value, and there it's been 7 years that we offer to all of the owners a report at the end of each year of the condition of the building. And starting 2 years ago, we're starting to integrate what could be done on the building, and starting in 2025, we will now starting to give them, I would say, a kind of business plan or action plan of what should be done on the building. So that's where we act. I mean, it's for the others. I mean, we act on behalf of the others, but that's what we do.
You can ask to Shatila to be better, perhaps in communication, as you said, perhaps to promote more.
For sure.
Why not?
For sure.
Before to give you the micro, because we have more time, so I was too much. But there is one thing I want you to say. It's not on your side, but it's linked to the PAV. 3 years ago, we had a question from the PAV, so FTI, Fondation des Terrains Industriels, Fondation du PAV. You are EPFL, will be nice to work with you because the PAV, it's a living lab, we need to have reuse and we need to rework on blah, 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 blah. And at the end, 3 years after, no project with them. We bring, it was super difficult, but it's not linked to you. It's linked to the public policies, to the public sectors, and to the risk assessment. There is a risk to let an area, or to be honest, but it's not linked to M3. But at the end, it's also the aversion of the risk. And I need to take risk and to let perhaps researchers to come and to put the feet on the real world and say that we can test on sound. We call it living lab. What we are looking for as a researchers is living lab, a place where we can play, but not to play, but to prove that it's working well. But the PAV was reminding the bell because 3 years ago I met all these départements du territoire and they say we need to work on the activity of the plan, and it was one idea to work also. So we have perhaps some tiny project, but the impact is, to be honest, zero. But just for the story.
Let's take the opportunity.
Yes, for sure. We have to. So it's the next step. Perfect. To have a follow-up. Cool. Commitment. How to engage on to Karen. How to commit. How to commit. You have to join the team of the Worldwide Sustainable Centers to be trained on after to go in the...
Well, you know, as I keep saying, it's not one thing, it's a multitude of things. We have to add everything together, you know? So I think we all need to try to contribute in our own way. And, you know, I'm not here to say this is the one answer, you know. We're in creating this center, this is precisely the idea. We're trying to bring together a multitude of people to more integrate the solutions. I mean, I hope we can at least make progress. I'm not saying we're going to solve everything, it's going to be perfect, but I think there's a lot to be done by people talking together as we're doing here and looking at different solutions.
I've got something fresh news also for you. I tried to invite Renaud d'Energie to be there, but they couldn't join. But for the story, the first question when they came, they said, yes, we want to be greener. You know, perhaps, but Renaud d'Energie is not only in energy provision, it's also in the real estate and so on. And they will call your team, LC3, and say that we will impose, because there is an open call, and they will impose to use the LC3 concrete. We'll see, but it will be the first impact locally. But I say, let's see how it will change the value chain for your project on the open call.
Yeah, but as I say to people, you know, it's not only the LC3 concrete that can be low concrete. There are many different low carbon concrete solutions, you know, and okay, we have a producer who started to produce in Switzerland, but also in Switzerland, there are lots of other cements which are low carbon. Switzerland is actually one of the best places for reducing CO2 impact. But we use too much of it. We have to use less. But anyway, thank you for this news. But I think
you anticipate also a question. It was, what is the place of the LC3 in the future of construction in Switzerland? So you answered.
Yeah,
honest.
I mean, as I say, we have one producer, but I say again, the impact we can have is not purely the impact we can. Well, it's only a tiny bit what impact we can have in Switzerland. The important thing is the impact we can have worldwide. You know, we can have the potential worldwide is equivalent to more than 10 times the entire emissions of Switzerland. And, you know, if we can have some more technologies coming out of Switzerland with these kind of multifactorial impacts, then, you know, it would be really great.
Exactly. We didn't talk about digitalization, but it's also a super topic linked to digitalization, sustainable construction, but it's another topic, perhaps another roundtable.
No, it has a big role to play.
But,
you know, particularly when we're making, you know, sometimes when we go to lower carbon concretes, they're a little bit more difficult to make, and their digital monitoring and things like this can play a very valuable role.
Sustainable digitalization, Fustic.
Yeah.
Okay, cool.
Okay.
Yeah, I mean, I fully agree with what's being said. So it's a complex issue, multidimensional one that requires a multidimensional answer. But at the same time, global warming is happening now, so we cannot wait. We need to. I mean, the solutions of tomorrow are the ones that already exist today. We cannot wait for 10 more years to have new solutions, and then for the time, it takes a lot of time for implementations. We understood it with Katrin as well. And so it means that we cannot wait for the solution to arrive, and I mean, everyone should get out of his comfort zone, whatever that means, and I mean, it can mean very many different things, getting out of one's comfort zone, and not wait, and making changes now and not in the future. Yeah.
So we need to act the change now. Not tomorrow, but now. But the final word will be for you both. So I know you, so you will commit everybody to join Rebuild, to come on the pavilion, and to help. No children because linked to the shoes, but you can come and we can make a super nice apéro and to organize that. Huh?
Yeah, actually, we are both looking for people who want to spend an afternoon, a day, or whatever time they want on the construction site. There will be probably this entire summer. We're looking for materials as well. If you know someone who's destroying your house, please talk to them. We would like to save a little bit of the house and take it with us in the adventure. I had two things to say as closing words. First, you cannot change anything by being alone, so just remember you're not alone. I was super scared, and this is going to join my second point, which is change the story. Change the story you tell others, change the story you tell yourself. I was scared 2 weeks ago. We were on the round table of Rent together, and I at some point said that there are many ways of being together that exist in nature. For some reason, we as humans have acknowledged that the only way we can be in the world together is by being in competition. And no, there are many other ways that other species interact with each other that don't involve any competition. And I heard that someone in the room had said, no, everything is competition. And so this is very dangerous when we tell those stories so many times in our heads that we think they're realities. There are other ways that species interact together. Why can't humans do it? They have done it in different societies in different parts of the world. You need to change the way you think about the problems. You need to change the story you tell yourself and the story you tell others, and you need to do it with the others.
So you need to be involved in the politics and to be at the Confederation. Thanks, Sarah. Luana.
Well, it's so cool. But, well, regarding Rebuild, what I'm amazed is that it started with 3 students only. 5. Maria's
Maria, yes.
It started with Maria here, and now it grows bigger and bigger. And what started with just student projects, testing out low techs, actually resonates further. There's like, well, talking here, but it's also talking in the media. Recently we had an article in a construction magazine. And well, this gives hope, because it started just with 5 people, and now it grows bigger, and we have to do this initiative. We have to believe to, well, show that it works, and just try it out. Oh, and we do visits of the pavilion.
Yes.
If you want to come. And also, well, call for materials. It's actually a job. So it's material hunting, which is a big part of reuse.
That's what she does.
Yes. So I just take advantage of the situation. So if you have earth, because we're building walls in earth, wood of all types of sizes, a door of minimum 90 centimeters to give, because it's a public building.
You are doing your shopping list, huh?
Yes, yes.
Sorry, yes.
No, it's really important. And also lighting elements or sanitary elements for dry toilets that we're testing out. That would be great.
Cool. I think we have some potential donors, so feel free to come and to offer this opportunity. So we try to wrap up, but at the end, it's breaking the silos, it's really working together to act the change. We are able to do a good job together, all together, to break the silo, not the competition, but the co-petition, perhaps. Cooperate, but to be competitors, why not? Yes, Sarah.
Yeah, I just wanted to say thank you to the opportunity we have to stay on the stages, because it helps a lot. Also spreading the projects that the sustainability series thought about our different projects, the ENAC and EPFL, because I was a bit harsh earlier, but we also got a lot of help from different people of every different domain. So just not to say that it's all grey, and actually we.
Thank you. I remember the first time when I heard Maria, I was crying, you remember? I was super shocked by what you said, because at the end it's really the truth, and we need sometimes to have clearly the message that we are able to do that, and be able to do that. We trust in us, and we are able to do the job. But at the end, so thank you. It was a pleasure.